suppose that insulators are provided to support these conductors, and they can insulate this live part of the conductor from the human bodies, or we can say that it will be insulated, or it can be insulate these live parts. Okay, so what are the different types of insulators? What are the properties of the insulators? Which are the different types of insulator that we have used in the power system? So that part we will see here. So overhead line conductor should be supported at the poles or towers in such a way that current from the conductor do not flow through the do not flow to earth through the supports. Okay, that means we should have line conductor must be properly insulated from the support. What will happen if you are not using the insulators, and if you directly laid these conductors on the line support, then what will happen? This line support carries the current, and directly it passes all the current to the ground. Why? Because this line support already it is buried into the ground. Okay, that means line conductor must be properly insulated from the supports. ठीक आहे, मग हे कसं केलं जातं? So this can be achieved by securing the line conductors to support with the help of the insulators. Okay, so how this it can be done? This can be done with the help of the insulators. These insulators provide the necessary insulation between the line conductors. Insulator provide the insulation between the line conductors and the supports. ठीक आहे, तर समजा तुमचा हा पोल असेल, this will be the cross arm. Suppose या cross arm वरती आपण जर suppose conductor, this conductor and this third conductor, if it is these three conductors are placed as it is, then what will happen? So this line conductors are come in contact with the line supports, and all the current is passed to the ground also. Okay, now I do to insulate from this line support and this line conductor we using the insulators. Okay, so this will provide the insulation between these line conductors and these line supports. Okay, and this will prevent this us to flowing the leakage current conductor to the earth. Okay. So in general the insulator should have, so this is the basic functions and the basic of insulators. Insulator का वापरतात तर just for insulating purpose. का कुठे insulation करण्यासाठी, insulating करण्यासाठी तर live conductor हे तुमचे line support पासून insulating करण्यासाठी we are using the insulators. ठीक आहे, त्याच्यामुळे क्रॉस आर्म असेल तर क्रॉस आर्म वरती you can see that we first there was insulator are fixed, and on that insulator conductor the top or bottom level of that particular insulator the conductor are placed. ठीक आहे, arbitrary किंवा randomly blindly आपण conductor line support वरती place करत नाही. तर line conductor कशाद्वारे place केले जातात? They can be placed in a line support along with this use of insulator. ठीक आहे, but what should this insulator should have the property? Which are the properties should have to be followed by that insulating material or the insulators? So that we will check here. First one is the high mechanical strength in order to withstand the conductor load, wind load, etc. That means it's having some mechanical strength. Okay, good mechanical strength. Again, the high electrical resistance of insulator material in order to avoid the leakage current. So obviously, the resistance, this is the electrical property. First is the mechanical property. So electrical property means it should has to be high resistance so that that current will not be passed through the earth. Third one is the high relative permittivity of the insulator material on other that of the electrical strength is high. Okay. Next, insulated material should be non-porous. There should not be any porous structure. They should have to be non-porous, free from impurities and cracks. Otherwise, the permit will be lowered. Okay. I think this part non-porosity and this why the impurities, how these impurities plays an important role in that breakdown strength of the particular material. I think all this terminology you have seen in the material science subject. Okay. So same terminology is to be here. Non-porous, the structure should be non-porous and free from impurities. Okay, free from impurities means suppose if anything having impurities in that particular material, so it will be disturb the breakdown capacity of that particular insulator. So high puncture strength flashover, that means a very high ratio of puncture strength voltage, that means it is related to the breakdown strength of the insulator. मग हे अशा प्रॉपर्टीचे कुठले मटेरियल वापरले जातात? सो दिस पार्ट इज मोर इम्पॉर्टंट as far as the MCQs are concerned. The most commonly used material for insulator of the overhead line is a porcelain. ठीक है, but a glass, steady line and special composition material are also used with limited extent. So line is porcelain structure is to be used for the making of these insulators. Porcelain is produced by firing at a high temperature mixture of kaolins, feldspar and this quartz. So these are the material through which we can generate or we can create this porcelain. Okay, porcelain material is to be used for the construction of this for insulators. It is stronger mechanical than glass, gives less trouble for leakage and less affected by change in the temperature. So change in the temperature is also very important parameters on this construction of the insulators. Why? Because these insulators are directly placed on in this environment, or they directly exposed to this environment. So some these environmental conditions are also affect on this insulator. So this is having the strong mechanism, it having the less affected by these changes in the temperature. So this property should be followed by, and such material which can be used, or some material is called as a porcelain. So there may be the question type following, which of the following material is used for the construction of the insulators, or they will asking like this, which material is better to use for the insulator. Okay, so this is porcelain. Now what are the different types of the insulators? Actually we having the 5 types of the insulator. One is the pin type of insulators, second one is the suspension type of insulators, third one is the strain type of insulators, fourth one is the cycle type of insulators, and last one is the stay type of insulator. So these 5 types of insulators which we are using, for the which we use this in the power system. Okay, so pin insulators. So have you seen this type of insulators? Diploma or direct secondary students, they have already got with this type of insulators. Actually they have seen this particular insulators also. Okay, but normally in practice or in day-to-day life, if you observe our poles very closely, we also see this type of insulators on these towers, or on these line supports. Okay, so the structure is look like this, and this is called as a pin type of insulators. Okay, you can just check here, this is the pin type of structure is to be there. This is called, that's why it's called as a pin type of insulators. Here again voltage ranges, we having the 5 type of insulators. So whether we can use, how these 5 type of insulators are used in the power system. So basically these insulators are used based upon the voltage ratings. So the part section of the pin insulator, which is to be shown in the figure, as the name suggests, the pin type of insulator is secured on the cross arm of the pole. There is a groove on the upper end of the insulator for housing the conductor. There is a groove is here, a small groove is provided. On that particular groove the conductor is to be placed. This is the sheet or a petticoat. Cementing is to be done, and this is the galvanized, the steel peel is to be inserted in middle section. Okay, this structure will be look like this after providing the overhead conductor on the supporting on this particular insulator. The conductor passes through this groove and bound and by the annealed wire of the same material as the conductor. Hmm. So pin type insulators are used for the transmission and distribution of electric power voltages up to 33 kV. किती लेवल पर्यंत यूज केलं जातं? This pin type of insulators are used up to 33 kV. Beyond the 33 kV, pin type of insulators become too bulky and hence they are uneconomical. So pin type of insulators are used up to 33 kV only. See, so this is the pin type of insulator which are provided. A small groove like portion is to be at the top surface, and he काय केलेलं असतं, so this simply it is to be rested on this line support. Okay, so this will be your line support, this will be your pole. So on this pole the line support is this cross arm is there, and this pin type of insulator are just fitted with the screw on this cross arm. Okay, इथं काय केलं असेल तो प्लेस केला जाईल, and here we have passed this conductor, or this conductor is to be placed here. Okay, so up to 33 kV voltage levels they can sustain, or up to this we can use this pin type of insulator. So actually this pin type of insulator will be look like this. Then the suspension type of insulator. See, this will be the suspension type of insulators. It having the disc type of patterns, 1 2 3 4 discs are provided, and at the lowermost point we have provided the line conductor. See, this the line conductor is provided at the lowermost point. Okay, just like this. So this will be the 1 2 3 4 5 6 7 8 discs are there. This will upper part is connected to the line across arm of the line support, and this with these discs are there, they can freely suspend it into the air, and at this lowermost point we have placed the conductor here. Okay, we simply we place the conductor here at the lowermost point. Okay, this is the most important insulator which we used in the power systems. This is called as a disc. ठीक आहे, आपण याचं डिस्क्रिप्शन बघू थोडक्यात. The cost of the pin insulator increasingly as the working voltage is to be increased. जर हा आपण हायर व्होल्टेजसाठी जर यूज करायला गेलो तर again we should want to provide the proper dimension of this particular pin insulator, and that proper dimension and with respect to the voltage if we see that two parameters, then the cost associated with that it will be increased. So this pin type of insulator having certain these limitations over the use of above the 66 kV. Okay, so therefore this type of insulator is not economical than this 33, not 66 but beyond the 33 kV. Okay, so for higher voltages that is more than 33 kV, it is to be usual practice to use the suspension type of insulators. ठीक आहे, सो मोर दॅन 33 kV लेवल्स जर आपण यूज करत असेल सप्लाय, तर मेजॉरिटी using the suspension type of insulators. They consist of number of porcelain discs are connected in series by metal links in the form of string. So this is the string like structure where the different number of these porcelain discs are to be connected in parallel with each other, are connected in series. Getting the conductor is suspended at the bottom of this string, while the other end of the string is secured to the cross arm of the tower. And this see, so this will be connected to this cross arm of the tower, and this bottom end where we have connected the conductor. So where actually this suspension type of insulators are used? Anyone? Have you seen the use of suspension type of insulators? Have you seen the suspension applications of the suspension type of insulator?
Yes, sir.
Where?
Near transmission line.
Okay, correct. Transmission lines means where we use the towers like structures. Okay, so large tower like structures are there. Basically, if the transmission line is to be there, okay, there's a differences between this line. If the line is to be for made is for transmission only there purpose, so there we use this type of suspension type of disc are provided here. Okay, so name itself gives the meaning of this, but you can vary this. Just check the number of discs. So number of discs it may vary, it will not perfectly full, but it count you, it will be vary. Okay, so conductor is suspended at the bottom. Conductor त्याच्या बॉटमला कनेक्ट केला जातो, तर upper part that will be connected to the cross arm of the line support. Each unit or disk is designed for low voltages, say up to 11 kV. प्रत्येक disk, तर तुम्ही म्हणाल की सर whether we place the any number of disks there, can we place the 2 disks here, can we place the 5 disks here? Yes, you can place number of disks here, but that number of disks can be depends upon the voltage levels. ठीक है, arbitrary provide केले जात नाहीत number of disk has to be specially designed, pattern needs to be there. So that's why this number of disks are provided based upon how the disk, each disk is designed for low voltage, say up to 11 kV. म्हणजे एक तुमची disk कोणासाठी यूज करू शकतो आपण, that can be used up to 11 kV. The number of disks in the series would be basically depends upon the working voltage. किती voltage ला तुम्ही use करता suspension type of insulator. Based upon that, we can check the size of the insulator, the size of the suspension type of insulator. For instance, the working voltage is 66 kV. Then we have to use the 6 disks in the series will providing the same string. ठीक आहे, म्हणजे इथे किती प्रोव्हाइड करावे लागतील आपल्याला. Suppose if you want to carry the 66 kV voltages, then it has to be we should have to be provide how much disk. So total 6 disk we should have to be provided. ठीक है, हाँ. So this is called as a suspension type of string. Hmm. Now we will check what are the advantages of this. This is the most important, as the suspension type of insulator most commonly used in the power system, and it having some biggest some advantages. Suspension type insulators are cheaper than the pin type insulators of voltages beyond 33 kV. Each unit of this suspension type of insulator designed for lower voltages up to 11 kV, depending upon the working voltage. Desired voltage this can be connected in series. Maximally, each disk carries the how much voltage? 11 kV. Okay. Suppose if you want to increasing your voltages, then obviously you should have to just increase the count of the disk there. Okay. If indeed any one disk is damaged, then whole string does not becomes unless because the damaged disk can be replaced by the sound one. Okay. The suspension arrangement provides the better flexibility to the line. The connection at the cross arm is much insulator string is free to swing in any directions and can take up the position with the mechanical stresses at many times. म्हणजे you can due to this suspended like a nature, so whatever the pressure which will be provided by the other external agencies, so that can be made minimized. So the fourth point is in case of increased demand on the transmission line, it is found that more satisfactory to supply the greater demand by raising the line voltage than the provide the another set of conductors. Okay. So in addition to insulation required for desired voltage can be easily obtained in the suspension arrangement by adding the desired number of discs. Okay. Suppose if we installed one line with a 66 kV and after some time we came into notice that now this line is not sufficient to provide the particular load. Yeah, therefore again I will increase the that particular transmission setup, distribution setup for the particular feeder only. So instead of that, what I have done, just I have increased what they have said. They have just increased the, if you increase for the disk there, so automatically you can adapt for the higher voltages. The suspension type of insulators are generally used with the steel towers, as the conductors run below the earth cross arm on the tower. Therefore, this arrangement provides the potential partial protection from the lightnings. ठीक आहे, lightning पासून का, कारण the conductor तुमचे खाली असतात and insulating part is lies above the ground, or also we can say that this insulating part is at the above. ठीक है, and this line part is from the lower side. ठीक है, so it will again provide the protection against the lightning arcs. So it will be visible in the suspension in case of tower type of structure. Next is the string insulator, but before that, the strings the strings are connected in series. Okay, so so what will happen? Here is one drawback is there. So can anyone tell me that what is the drawback of the suspension type of insulator by adopting this type of structure? Yes, please. What is the disadvantage? Huh?
ट्रेनचं स्ट्रक्चर नाही दिसत सस्पेन्शन टाईप दिसतंय.
जर आपण असं सस्पेन्शन स्ट्रिंग टाइप ऑफ जर यूज केलं, दिस टाइप ऑफ स्ट्रक्चर जर असेल सस्पेन्शन स्ट्रिंगचं, तर याचा डिसएडव्हान्टेज काय आहे सांगा?
The gap,
Sir, gravitational force.
येस, अगेन.
gap. There is a lot of there is gap. So,
Now check what will happen to if we use if we use this type of structure as it is in the power system. So this is the conductor. See, just a minute. I'll change here color. No, check. So conductor is placed here. Okay, and now this conductor is to be carrying, suppose 132 kV line is to be there. That means it will high voltage is nearer to this disc. As compared to this first disc, what will be the voltage here? It will be somewhat less. Again, up to as compared to this here, again this voltage will be less. Okay, so here is also less, here is also less. As compared to voltage, compare up to this voltage, here is also less. As compared to here, here is also less. That means you, if you observe here, so voltage appear across this disk is more, it is to be very more, it is to be very more as compared to the voltage which will become across this last string. Just a minute. This last string. Okay, so it is very small. Getting? So what will happen? So this will produces a non-uniform distribution of voltages across all the disk. ठीक आहे, प्रत्येक डिस्कच्या अक्रॉस कसा असला पाहिजे, व्होल्टेज लेवल्स कशा असल्या पाहिजे, इट शुड बी सेम. अदरवाइज व्हॉट विल हॅपन, continuously this last or the disk which is nearest to the conductor will experience high voltages, and after some time this will get punctured or this will be get damaged. Okay, and if one disk will be damaged, that means your whole insulators will be get damaged. Okay, so this is the biggest disadvantages if you use this suspension type of insulators. Okay, now how we can make this voltage distribution equally? So that purpose we having some methods. Okay, so that is we call it the string efficiency. So first you should have to calculate the string efficiency, and from that string efficiency you should have to provide some methods here, so that you should have to provide some methods. By using this methods, we should get the voltage across all the disks should be same. Getting? So string efficiency is there, and the string if thereupon as it is this the structure which is to be shown in the figure the use killer. So what will happen, the string efficiency will be less, and to improve the string efficiency we have to be mention some methods. Okay, I think in the first list, that is the guard wire, use of the guard wire, making the equivalent capacitance equal. So lots of methods are there. I think 2 or 3 methods are there. By adapting that 2 or 3 methods, we can actually make the voltage distribution on the suspension string should be uniform. Okay. Next is the strain type of insulator. So strain insulators, when there is a dead बघा strain type of insulators. So strain type of insulator at the tail end of the line. ठीक है, जिथं line end of the line.
Your voice is breaking.
Just a minute. Now check. When the or the curve, sharp curve is there. So at that condition, hello. Now
आवाज नहीं
is it okay?
Your voice is breaking.
Just a minute. Just now check. So where these strain insulators are used, they are used at the dead end of the line, or they are used at the corners, or they are used at the sharp curve. Okay, where the greater tension is to be there. When the greater section is to be available, so at that particular condition we use this strain type of insulators. So in order to relieve the line of excessive tension, strain insulators are used. For low voltages of line less than 11 kV, shackle insulators are used as a strain insulators. Shackle insulators आपण आता next step मध्ये बघायचं आहे. ठीक आहे. So basically at the dead end of the line, sharp curves किंवा corner या ठिकाणी कुठले for higher voltages we using this strain type of insulators. For higher voltage of the transmission lines, strain insulator consists of the assembly of suspension insulators, which is to be shown here. The disc of the strain insulator are used in the vertical plane when the tension is line is exceeded high, as at the long river spans the so two or more strings are used in the parallel. So excessively higher tensionच्या इथं basically this strain insulator use केले जातात. ठीक आहे. This suspension insulators more than 3360 kV voltage साठी यूज केले जातात. पर्टिक्युलरली strain insulators कुठे यूज केले जातात, तर ज्या ठिकाणी तुमचं टेन्शन हाय असतं, at that particular places we use this strain type of insulator. ठीक आहे. So this is the actually strain type of insulator. So pole is there, so this can be in the vertical. See, this will be the one disc again. Again one disc is to be used here, and this conductor is connected to this string of the strain insulator. This is the pole actually.
दोन पोल थोडं
Hello.
सर दोन पोलच्या लाईन कनेक्शन साठी याचा यूज होतो ना. दोन इलेक्ट्रिक पोल्स आहे तर त्याच्या लाईन कनेक्शन साठी आपण याचा यूज करतो ना.
येस, बट ॲक्च्युली दोन असं म्हणता येणार नाही, पण ज्या ठिकाणी तुमचं टेन्शन जास्त असेल, सो बेसिकली ॲट द डेड एंड्स ऑर द क्रॉसिंग असेल, तर त्या ठिकाणी जिथे एक्सेसिव्ह टेन्शन्स असतो, सो दॅट टाईप वी युझिंग दिस टाईप ऑफ strain type of insulator. ठीक आहे. So this is actually number of disc which is to be required there, and insulator used in strain insulator. Suspension type मध्ये किती यूज केले जातात, आणि this I think this chart is to be showing there, so this you can check this afterwards. Number of disc in the insulator used in the strain type of tension strain type tension insulating string, and number of disc insulator used in the suspension insulator string. ठीक आहे. सस्पेन्शन टाईप असेल किंवा स्ट्रिंग मध्ये असेल तर number of how many discs are we can use for that particular voltage level. So number of that particular disk are given here. And the last type is the shackle type of insulators. The shackle type of insulators, is also same type of strain type of insulators, uh, but this shackle type of insulator which can be used for the smaller voltages less than 11 kV. So in earlier days the shackle insulators were used in the strain insulators, but nowadays they are frequently used for low voltage distribution lines. Such insulators are used can be used either in a horizontal position or in a vertical positions. They can directly fix on the poles with the bolt or the cross arm. आता normally जे का आपल्याला outside जे का poles असतात in the road itself, so there you can check this type of shackle type of insulators. ठीक है, the conductor or grooves is fixed with the soft binding wire. You can just check हा त्याचा जो का पोलला हा फिक्स केला जातो. So on here this shackle insulator is to be here, आणि इथं तुमचा या middle sectionला काय केलं जातात here this conductor is to be with the winding wires, the conductor is to be connected. Okay, so normally the shackle type of and strain type of insulator are used at the means shackle type is used for the lower voltage level for the reducing for higher tension itself, but it will be used for only for lower voltages. For higher voltages we can go for the strain type of insulator. And the last part of the insulator is the strain insulator. Okay, आता ह्या बघा, for lower voltages lines the stay are to be insulated from the ground at the height. Okay, so the insulator used in the stay wire is called as a stay insulator. Low voltage lines the stays are to be insulated from the ground at a height. Okay, so the insulators used in the stay wire, it is called as a stay insulators, and usually of porcelain, and so it to be designed to in case of breakage of the insulator as the guy wire will not fall to the ground. Okay, that's on the suppose I will draw it here. This will be the pole, your line support, or we can say that your pole is there. These are the transmission line, and from this, see, this is to be one wire is to be there. This is called as a guy wires. Okay, so here somewhere we using this type of stay insulator. Okay, so in this portion we using this type of insulators here. ठीक आहे, हे नॉर्मली डिस्ट्रीब्युशन साईडला डिस्ट्रीब्युशन साईडचे जे का पोल्स असतात, तर नॉर्मली यू कॅन चेक दिस insulators are placed on this types of pole basically at the distribution sites. ठीक आहे, जर तुमच्या घराबाहेर जर तुम्ही पोल्स असतील तर you can directly check there also on guy wire is to be there for that stressing purpose. On that in that particular stage this three type of insulators are used. Okay, so that's all. These are the 5 types of the insulators are there. Now we will stop here, but in the next lecture we will see the string efficiency. What is meant by the string efficiency, what is the actual count of the string efficiency, and how we can improve the string efficiency. What are the different method through which we can improve the string efficiency. Okay, so this is the last point of this unit, and that we will cover in the next lecture. Okay, this string efficiency is related to the suspension type of insulators. Okay.